Shrijeet, Rochan, it's been about a year since I was last in the office, and I always say that semiconductor years are like dog years. So much changes so quickly, and a lot has happened in the Enfabrica world, and a huge kudos and congratulations to both of you on some huge milestones.
Thank you. Thank you.
Absolutely. So let's see, in the last year, 3 major things have happened. You guys taped out, 115 million in Series C funding. And just on Monday, there's been an announcement from DeepSeek that's thrown the whole industry up in arms. So would like to talk about those things in whatever order you guys would like. Maybe we start actually with the recent news, the DeepSeek. How do you guys see that affecting the AI machine learning hardware world?
Yeah, to be honest, I think it was an anticipated, maybe not in the exact same form and with the geopolitical implications that sort of have been interpreted about it. But what DeepSeek represents is the increased efficiency frontier of compute that's going to give rise to much more deployment of AI compute and standing on the shoulders of the work that we've already done. That's really what it's about, right? It's about progress and making progress really fast. The way I look at it is like, Jeff Bezos has a great piece of advice for startup founders, which is, or anybody who's trying to run a business, which is like, you don't try to service the needs that are like this year or next year. You service the needs and the pay points with your business that are problems for decades, persistent problems. And so the way we look at it is like, we're building at Enfabrica, a palette of technologies around interconnecting AI compute resources, accelerated compute resources, and the movement of data to maximize efficiency for what we think is a problem that is going to persist for, those decades. What DeepSeek says is effectively accomplishing is getting to the next frontier where the next set of problems that have to do with data movement and efficiency of compute have to be optimized. But it just increases the available TAM, in my opinion, even though there might be a short-term implication on like, hey, what happens to orders or plans in the next 3 months, 6 months? Do people pause? The bellwether is actually very positive overall, and I think the market's actually reflecting that sentiment. It's not like the market crashed for 3 days straight. Market crashed for 1 day, and everybody sort of like really was like, okay, we corrected some valuations maybe. Maybe some over-exuberance previously, but I think it's actually a good sign for competitiveness around the platforms.
Excellent. Shrijeet?
Yeah, so on a sort of a direct applicability perspective, right? Like we've always said that the vast majority of the market is going to be around fine-tuning and inference. And if you look at fundamentally what DeepSeek has done is they've basically come up with a reinforced learning version of fine-tuning. Right? So everything that Rochan said, you build on top of models and technology you understand, and you expand it very aggressively in certain directions with scarce resources. That's the other reality of this situation. They did not start with cost is no object, size is no object. Let's build everything vertically integrated so that we can hit some imaginary future milestone. So if you think of it that way, again, that's exactly the playbook we've been playing to, right? Which is you're going to build from best of breed, you're going to build from components that are disaggregated, and you're going to target things and areas that are very, very directly applicable to you, and such that you can consume the results right away. That, to me, is the most significant portion of DeepSeek, because if you look at everything that they did, whether it's MLA or better MOE or this reinforced learning scheme, it wasn't that they said we have this new scheme that no one has ever thought of before. But it was a formulation of the components using strategies that have been thought about before, but putting it together in a way that was actually very efficient. And they maximized utilization everywhere, right? And that's exactly where we think we can be very helpful.
Yeah, absolutely. And one of the things that has drawn us to Enfabrica is a long-term view and the fact that you're not just trying to build another accelerator. You're an enabling technology. It's the same thing that initially drew us to Astera. And can you guys talk a little bit about the tapeout and what that means and where that brings the company to today?
Yeah, I mean, obviously, it's the holy grail of what, as a semiconductor company, you need to get to. I think what makes this one, more uniquely special is that it's a tape out of a chip that actually has never been taped out before, right? This type of permutation, we didn't change laws of physics, right? I mean, semiconductors are semiconductors. But to take what was the default server interconnect component, a NIC, which has been basically of the same shape and form for, a few decades now, evolving from desktop all the way to cloud, and to reconstruct that the way we did as we call it a SuperNIC, but really it draws upon, capabilities as a multi-port PCIe bridge and switch, capabilities as an RDMA NIC, an array of RDMA NICs, and cross-connect fabric on both sides of that, as well as an Ethernet switching layer facing the network. And the permutation of that and having software be able to control that, to be able to drive that, all those pieces coming together, that's what made this tape out, I think, significant for all of us here, because it was basically taking something concept that was a forward-thinking formulation of what would be super beneficial to accelerated computing systems, and proving that that actually can be taped out in a competitive envelope of PPA, power performance area, and taking that on. So what we're most excited about is that tape out really is and the silicon that we are now putting in systems like this one to actually demonstrate that functionality to customers this quarter and next, and for the remainder of 2025 to ramp into their production volumes. It starts the counter for building an entire product line off of this. And so the next project isn't 100% redo of what we did previously. It's like now to the point where you ride the experience curve of 20% improvements and then 30% improvements, but to get to a faster pace of actually driving product into the market.
So at a high level, if we're to break it down, why should somebody buy your product?
There definitely is a focus on building better systems out there, and everybody knows that communication, interconnects, and AI and networking plays an important role. But why Enfabrica? Why the accelerated compute fabric SuperNIC specifically? And it really comes down to three things that that are founded on very deeply technical value proposition pillars, but they run all the way up to how you build data center infrastructure. The first one is shared is better. When you think of the resources that you deploy and the systems that you deploy, shared resources create complexities because they're touched on by multiple units, but they create efficiencies. They create efficiencies of being able to say, oh, I don't strand something, all right? Or I don't strand a set of resources. That utility can maybe be more efficient if it's shared across. We build a SuperNIC that is shared across multiple accelerator or memory or processing endpoints. And we've proven through simulation that sharing is better, which is different from what the existing default design in, which is, dedicated is better, right?
Yeah.
The second one is we want to arm customers to be more resilient in their AI architecture, meaning these systems, if they're brittle, they cause problems. And right now, these systems are actually fairly brittle, right? In terms of just infant mortality, how much has to go. There's obviously delays in some of the systems that have been planned for deployment, and it's part of the fact that it's just not quite reliable the way it's built. Contrast that to how data center, conventional design was with servers. It was hugely reliability and resiliency was a huge part of the system architecture. Our solution enables those customers to be more resilient. And the third part is simplify and take control. Meaning you have a prescription for how the system could be built. It might be available, but it's complex and it's built based on a vendor blueprint. And people follow that blueprint because there's a massive race to kind of go and deploy now. But if you pause to think about, like, am I complicating my life or am I simplifying my life? What we're espousing are choices in design that simplify the problem, reduce cable complexity, enable text to be able to go, wire very flexibly, not create, brand new problems to solve like congestion control for packet spray. Leverage the things that are easier. So there is a simplify aspect, and part of simplify is also delivering control back to themselves, software control specifically. Instead of having software layers that are packaged and supported by vendors to get this entire control plane and management stack, we're basically saying delivering through a communication stack that the customer can control. When I say control, I'm not talking about configuration. I'm saying they own the code. Then you're now getting back to the type of model where the infrastructure layer is a bunch of best-in-breed components, where the customer owns the management layer, the data plane software layer in the infrastructure, the resiliency layer, but they can then delegate the rest to the best-in-breed vendors in each space: compute, memory, data store, and networking. And we are that for networking.
That's awesome. And I think that you're going to come up against a lot less resistance than you have in the past. Shrijeet, can you talk a little bit about customer reaction that you've received in these early days?
So, maybe even to expand, continue where Rochan stopped, right? Like, I've always said this is an idea whose time has come, and a tapeout is really the coming of time, right? Because till then it's not real. And we've been doing a lot of simulation data in preparation of what we're going to produce. And with all the components modeled that we need, the software, the ecosystem, the accelerators and the like. And we've always had this experience. The universal answer or the universal reaction has almost always been, yes, this is the right way to do it. Now we have to worry about all the other nitty-gritties, like how do I integrate your stack? How do I make things work? How do I put it in a box? How do I make the chassis work? And things like that. But the general concept of what we've been talking about, which is an expandable, fungible interconnect that allows you to scale up your system the way you want to do it, and also be able to adapt to different machine learning algorithms, different data movement patterns that are being sort of superimposed back onto the hardware, that has resonated very, very well.
And it's not without controversy. We are, kind of forcing customers into the evaluation of, should I be continuing to build this as a vertically integrated system, right? Which is what the incumbent form of AIs are, whether it's a hyperpod or a rack scale system from one vendor, incorporating it all, or maybe in-house built, soup to nuts, to a horizontal best of breed approach. Does that get them to build better systems? Does that put them on a track to be able to get to greater levels of flops utilization, or better resiliency, or better performance and job completion times? What matters for them, right? And it's this kind of risk-reward weighting, right? Whenever you're a startup, the risk seems high to work with a startup. And then at some time, that reward part of the factor starts to dominate. That's what makes this time super interesting, because we are challenging the status quo.
Yeah.
We're not minimizing that. We're not coming in and saying, like, no, this works just fine with no changes to what you're doing. Like, no, we are going to, contend that this approach is better. But we all obviously are listening for the feedback on the constraints, what risks they can tolerate, what kind of system, flexibility they can build with, what they can't build with. So all those factor in, but that's what makes it such an exciting time to be building new tech in this space, is like pushing the envelope and seeing where you succeed. The reality is you don't need, 10 or 15 customers to go and do that. Yeah, eventually you do. You need a few. You need the early adopters who are going to take that risk and that risk-reward equation, in this phase. And we have plenty to choose from in order to be able to go make that happen, it's a matter of being in lockstep with those customers as we push this silicon through and our software through to production in 2025 and driving the next generation off of that.
The other big news that happened very recently, you guys closed on Series C funding, 115 million. What does that mean for the company?
It allows, so again, to continue maybe from the previous point, like if you think of what we are doing in terms of challenging status quo, the most important part is we are basically saying that disaggregation, which eventually wins, this movie has been seen multiple times, will be the way in which future AI systems will be built. And you're not going to basically take down your vertically integrated stack every time you want to try something new. That's not really very practical. So what it allows us to do is effectively sort of grow out our entire ambition of building all the components you need to be able to address these AI systems that are really taxing on every dimension possible, right? It's pushing the limits on bandwidth, it's pushing the limits on physical interfaces, it's pushing the limits of how many ports need to talk to how many other ports at what latencies and speed. So those are the areas that we will grow into, and of course, in the near term, we will use that money to make sure our product is the best in class for the solutions we need to attack.
So obviously, Shrijeet looks at it and be like, yeah, it's another pot to go build and explore more technical avenues. I have a more simplified answer for this. It's an endorsement that, look, to get to this stage of a company in the semiconductor startup space, you know this, right? You have to pass a whole bunch of barriers, right? There might be tons of people who start new companies at seed or Series A, like to get through all the combination of challenges, constraints, and breakthrough barriers that you need to get to this point, right? To get to scale, to have 100+ engineering teams that can build product, to be able to afford the massive amount of expenditures you need to build systems, to build test beds and the like. There's only a few companies that can get to that space. In this space for AI networking, we're one of the very few. We're fortunate, but we're one of the very few to get to this spot. So we're absolutely thrilled that an investor syndicate, with our existing investors and multiple great new names, Spark Capital, Maverick, ARM, Cisco Investments, Samsung Catalysts. This is an endorsement of the fact that many are looking at us as being sort of like the pace setter on startup innovation in this category of networking for AI and accelerated computing, and we've now got the gunpowder to go and address that broadly with our first generation products, and then to parlay that into the immediate next generation, which we've already started development on, and is going to be products that we're not talking about yet, but that are going to hit in late 25, in 2026. To take this forward. So, it's basically the continued path that we expected to be on at this point. But it's good to have the ability to scale as aggressively as you need to with that approach, with the support of a very strong investor syndicate to go attack this problem.
Absolutely, and you talk about scaling. One thing that hit me like a ton of bricks when I walked through the door, we had to use a new room. Everything's full here. You're adding people as well. Can you talk to us a little bit about the growth plans and how you keep the talent density that you've been able to attract with also maintaining the culture that we talked about a year ago of being builders, people who want to build. And you're a different company now too. You are moving on to Rev 2. So how do you attract builders and continue to scale and maintain that high talent density?
I think it actually follows quite seamlessly from where we were before. When you have a bigger organization, you have bigger surface of touch points. But your bar, our bar has stayed the same. It's very high with respect to what type of talent we're looking for. The fact that we want people who can synthesize across a very broad hyper productivity, right? Communication, just all the things that we look for in technical skill sets. We're still a very engineering-focused organization, unlike other, like we're not a sales-focused organization in terms of like a significant, portion of our organization has to be that way. That's fairly consistent for chip startups, especially chips and software, being of equal weight inside of a company like ours. So our bar has stayed fairly consistently the same, but we have more touch points to the outside world because of our scale. There's more awareness and spotlight on us, so we're able to leverage that into getting a bigger talent pool coming in. But we're still pretty selective, so we're not adding 100 salespeople a month. Right? We don't have to.
Yeah.
We get the leverage we need from just our organic growth.
But we are adding geodiversity.
We are. Yeah, you talk about it.
Well, we are expanding in India. We just established an India outfit, Enfabrica India Private Limited. And the idea, I mean, that is exactly to Rochan's point, right? We are looking for growing talent in places that meet our bar, but have a much higher population density we can pick from. And we've actually, it's not just India, we've expanded our hiring in the rest of the United States. We have some European hires now, and so on and so forth. So the good news for us was that we were born during the pandemic, somewhere in the middle. And so we were always built such that we can support remote operations, we can deal with engineering teams that are anywhere in the world and know how to integrate them into our pipeline. So that's an area that we've exploited quite a bit, and we plan to do more.
Yeah. For the benefit of everyone, we've got offices in Mountain View, North Carolina, and India, and we will be continuing to hire, aggressively in those 3 locations.
So oftentimes the best engineers are not going to be looking. They don't need to look. And so if there was an engineer who was open-minded to hearing about something else, and you wanted them to be Enfabrica curious, what would you tell them today?
Do you want to change the way system architectures for AI are going to be built in the future? If yes, come work with us.
There's companies and organizations that claim to be innovative and are pushing the boundaries of innovation. There's certainly a lot of innovation going down in the industry overall. Are you and do you want to be at the very point of being able to do that, like at the very crux of it, or are you surrounded by innovation and you're a cog in the machine? I think that's really, like, every one of our engineers is empowered to actually go build better. That's what I would be asking each of those engineers is like, do you want to build better, or do you want to be able to say that I was part of a group that does a lot of things that could be building better?
Well, I can't wait. Hopefully it's not another year that goes by before I'm in this office again, and something tells me it won't be, but really appreciate both of your time, and congrats again on all the huge news.
Thank you.
Absolutely.
Appreciate it.